The new topic we're going to talk about is correlation. And the first thing I'm going to do is show you a calculator screen. So I'm going to give you some data of some ages and weight, and we're going to do some analysis on it. But the first thing we need to do is learn how to create this particular graph. So if you will turn your calculator on and go to Stat Edit, we're going to type in two lists this time. So if you got information, just clear it out. We're going to set the first list at age. And so I don't want to necessarily make you watch me type in all of these numbers. So I'm going to pause this real quick. Okay, now one thing that's different, not necessarily different, but it does matter that they're lined up correctly. So you do want to confirm that you did type the data in right and that the proper age is across from the correct weight. Here we got 49,103, and that matches in the chart here. Okay. Now we're going to go to stat plot, and I've got my plots turned on because I can see the on there, and I've got my current thing set at a box plot. So I want to go to what a scatter plot is. So a scatter plot would be, let me kind of scroll off the side here. This bunch of dots that they've got on there, that's how they indicate that you're dealing with a scatter plot. And it's gonna say, well, do you want me to go list 1, list 2? X's are in list 1, Y's are in list 2, and that sounds great. And then we'll go zoom stat, so number 9, and it should give us our random, should give us our scatter plot, and then we'll talk about some characteristics of that data. Okay. Okay, so let's do a little discussion then about what we notice here. So as we're looking at this smattering of dots, is there a relationship that exists between weight and age? And not really. I mean, it kind of looks, it's kind of all over the place. It doesn't really look like there's sort of a specific relationship here. But we're going to change the numbers. So we're going to look at this set of numbers and see if there is a difference. So go back to stat list and edit. And let's see, it looks like the weights are the same and we're just changing the ages. So 74, 65, 77. Yeah, I mean, technically, you can clear out the two lists and start from scratch, but we're just modifying this. So let me pause this so you don't have to watch me type all these. Okay, so I've got the numbers typed in, and I'm going to go back to Zoom Stat and then take a look at this particular data. And what do I notice? Do I notice there's a more defined relationship? Yeah, I notice as age increases, so as you go from here to here on the x-axis, as age gets bigger, the weight tends to increase. So it does look like there's some sort of relationship that exists. Then we have to kind of think about, is it a positive or strong? And again, right now this is our opinion because we're learning about how one makes these decisions. But I think it's safe to say that as age increases, weight increases, and that definitely would be a positive relationship. That as X gets bigger, Y gets bigger. And is it weak or strong? They look pretty tightly knit. They look pretty close together as far as it looks like there is some sort of line that I can use to predict, and they look pretty close to it. So I'd say the grouping of the points allow me to suggest that it's a sort of a stronger type relationship. Okay, so that said, make sure I got this all on the screen. We're going to jump to here. Yeah, so the closer the points are to a straight line, the stronger the relationship is. Whereas the first graph we looked at didn't really have any sort of graph. They're pretty far apart and didn't look like there was a positive anything going on, so we would say they're weaker. Okay, so if we're going to identify something as having a positive, negative, or no association, we're going to look at some scenarios and kind of think to ourselves, what would one expect when we see something like this? So heights of mothers versus heights of their adult daughters. I think genetically there's a relationship, and I think that's positive. As mothers get taller, I'd expect their daughters to be taller. Age of car in years and its current value. So as the car gets older, what's its worth tends to decrease. So I expect there's a relationship. Weight of a person and calories consumed. So as their weight increases, I'd expect the calories to be, they expect them to eat more. Height of a person and a person's birth month. I wouldn't expect any relationship there. Number of hours spent in safety training and the number of accidents that occur. So as you learn more about the consequences of bad driving, for example, I would expect the person to be a little more obvious, a little more aware of their surroundings and try to make better choices. So I'd expect that to decrease. Okay, so that brings us to what we get to our first definition, a correlation coefficient. This is a numerical measure that gives strength and direction of a linear relationship between bivariate quantitative data. All right, so let's go back and translate this for a second. The correlation coefficient assumes we're dealing with linear, and so we'll talk a little bit later on how one can confirm whether or not we have an appropriate linear relationship. But the number itself, so it is a number, and the number indicates whether the relationship is strong or weak and whether it's a positive or negative relationship at some point. We use something called Pearson sample correlation, which is that R. They've got other statistics courses will show you other types of analysis out there. If we're talking about population, we use the Greek symbol rho, and if we're talking about a sample, we use R. And the formula is right there. We calculate our R. We take our observed minus our mean divided by our standard deviation of the sample, and we multiply all of these things together to figure out what the R is. Now, on a positive note, there's a calculator screen for that, so I'm not too worried about making us do that one by hand. Okay, so let's take a second and type this in to the calculator, and then I'll show you how to get R. Okay, so we're going to start by inputting our data into stat list. So I'm going to clear out these other numbers. And then just type in that. So I'm going to fast forward this so you don't have to watch me type. All right, now that we've got the data typed in, we're going to go over to, let's quit out of this. And let's go to stat again. We're going to go to calc. And we are going to have the calculator do a linear relationship because that's what R tells us as a measure of a linear relationship. I know right now we haven't confirmed it's linear, but we want R. So we're going to hit go to linear regression. Now notice there's two choices here for linear regression. There's number 4 and number 8. They both do the same thing. One is saying that the dependent variable is y versus the dependent variable is x. Doesn't really matter because we're going to look at properties of both here in a moment. So just pick the first one, linear regression, and it's going to say the x's are in list 1, yes. The y's are in list 2, yes. If we had a frequency list, so if there was like what I call histogram data, where it was counts of objects, and we wanted to tell the computer that, then I would tell it which list that information is stored in. We don't have that. Now this one's interesting. I want us to get in the habit of doing this, so I'm going to tell us to do it now. It's asking us if they want us to store the regression equation, and I do. I need to tell it where to store it though, and that's going to be under the variable menu. We're going to go to yvars, and under yvars we're going to pick the y1 function. Okay, and all that's going to do is just when it does this calculation, it's going to remember it in the calculator. Alright, so then I hit calculate, and it does all that fancy stuff for us. Alright, it seems I did not turn a feature on in my calculator. So if you see this, then you can join me and we'll turn it on together. If you don't see this, that means your calculator's already had it done. It seems I didn't turn my diagnostics menu on. Now, I know you wouldn't know that. So I need to go tell the calculator that I want you to do analysis. I know it sounds silly, but so I'm going to go to second catalog, and I'm looking for the phrase diagnostics on, so I can scroll down. Matter of fact, this catalog feature is a list of all the different functions that your calculator can do, most of which we won't use, but if you ever get lost and try, like, I don't know where this button is, you can try to find it here. Anyways, so I'm looking for the phrase diagnostics on, and I see that, so I'm just going to hit enter. Now this is technically something that one should only have to do once in the lifetime of their calculator, unless for some reason you turned it off. So I just need to go back to stat calc and then redo the regression and tell it to store it under y1 again. And this time, when I get R, or I should get R, because now it'll tell me R. Okay, so and notice R is pretty big. R is almost 1.99. That's a really strong R. So let's talk about how one interprets that. So once we've got that, so our sentence about this is that we have a strong positive linear relationship between, and then in context, what do X and Y mean? That would be speed limit and average accidents per week. Okay, so I'm going to pause here so I can switch to another. I don't want to make too many long videos.